Bright QT. Every student matters.
Hello dear students, the next topic is electric potential and potential difference. Let us study what exactly this thing means. Now first of all, before studying electric potential, you need to understand one or two odd things. That is, what is exactly an electric field? Electric field. We all are aware of magnetic field. Magnetic field means that area where the effect of a magnet is felt. Similarly, when we talk about electric field, it is that area where the effect of electricity is felt. Fine. Now, keeping this electric field aside, second thing we need to understand is that there is a unit positive charge, a unit charge, probably positive charge. This unit positive charge is anywhere around this electric field. It may be near the electric field, it may be far, it may be very far. What we need to do is, we need to bring this unit positive charge from that particular point where it is right now into a particular point in an electric field. For that purpose, we need to do some work, right? And that is what our electric potential is. First of all, let us see how we are going to define electric potential, then we will understand it. Electric potential can be defined as the work done in bringing a unit positive charge from infinity. It may be anywhere, right, from infinity to that point in an electric field. Now let us explain it and understand it properly. We have taken an electric field. This is an electric field that I have drawn. Let it be a point. We will just mark it as A, right? This point A. Now what I will do is, I will bring this unit positive charge from infinity to this point A in this electric field, and the amount of work done for doing so, for bringing this unit positive charge, that is known as the electric potential at this particular point A. Fine. So electric potential at a particular point in an electric field is defined as the amount of work done in bringing a unit positive charge from infinity to that point, right? Now this electric potential is basically having the SI unit of volts, which is represented by capital V. Fine. Now after understanding electric potential, we need to understand one more term. That one more term is potential difference. Now when I talk about potential difference, I am talking about the same electric field, any electric field I will take. Now I will be taking 2 points, one is point A and one is point B. Fine. The electric potential at point A is the work done in bringing this positive charge from this particular location to this point. I will be doing some work. Fine. Similarly, I will be doing some work for bringing this positive charge from infinity to this another point B in the same electric field. So electric potential at point A will be different, electric potential at point B will be different, and the difference between these two electric potentials is known as potential difference. Now how it can be defined? Just try to relate. Potential difference between 2 points. Now I am talking about point A and point B. Between 2 points in an electric field, there are two different points taken in the same electric field, and we are going to calculate the potential difference between these 2 points. Fine. So potential difference between 2 points in an electric field is the amount of work done. Same as we have done above in the case of electric potential, it is also the amount of work done in bringing a unit positive charge. We are bringing this charge from A to B, from one point to another, from A to B. That means the amount of work done in moving this charge from this particular point A to this particular point B, this is known as potential difference. Fine, right? Or we may also say that it is the difference between the individual electric potentials at the 2 points, right? Very simply saying, for example, if the electric potential at point A, we say it is 120, the SI unit was volts, and the electric potential at point B is 160 volts. So the potential difference will be just the difference between these two. That will be the higher value 160 volts minus 120 volts. So my potential difference will be of 40 volts. Fine. Another way of calculating the potential difference. Now this potential difference is also termed as voltage. We are more familiar with this particular term, voltage, in our houses. The voltage is low, the voltage is high, right? And the SI unit is again volts, which is represented by capital V. Got it? So this is our potential difference. Now two another more things that we need to relate over here is, first thing, there is an instrument to measure this potential difference. Instrument to measure potential difference in a particular circuit. That instrument is voltmeter. Meter, you are aware, to measure. Meter means to measure. What? To measure volts. Volts is the unit of potential difference. So to measure volts, to measure potential difference, this voltmeter is used. Another thing, in any circuit, this potential difference is maintained by a battery. So battery is a device which maintains the potential differences between the circuits. We will be talking about batteries a bit more in detail afterwards in the same chapter itself. Fine. So this is about potential difference. Now we said that potential difference was the amount of work done in bringing charge from one point to another. So when formula wise we try to relate potential difference short formed written as P dot D dot is expressed as the amount of work done divided by the amount of charge moved. So potential difference can be expressed as work done upon charge moved. Work done I can express as WD, charge we express is at capital Q. Potential difference is expressed as capital V for volts, right, or voltage. So potential difference is equal to work done upon charge moved. In earlier classes we have studied that work done is also equal to energy. That was something that we have obtained from Joule's experiment in 9th class. So because work done is also equal to energy, so I can also write potential difference is equal to energy upon charge moved. This energy can be kinetic energy or potential energy. It is not important which energy is given. Energy is equivalent to work done. Fine. The actual formula is potential difference is equal to work done upon charge moved. Now we have said that the SI unit of potential difference is volts. Fine. The SI unit of work done, or in that case energy, both is joules, and the SI unit of charge, we have read it earlier in the chapter, is coulombs. Fine. So volts is equal to joules upon coulombs. Now, two questions arise out of this. The first question that we will be asked is define volts. Now, when I am asked to define a particular SI unit, just the SI unit, I will simply say that volts, it is the SI unit, standard international unit of potential difference or voltage. Fine. Simply it is the SI unit of potential difference. But the important thing is, if I am asked define 1 volt or define 1 volt of potential difference. Now, whenever we are asked in this sense as to define 1 volt, we always define it with the help of the formula. Now, in this formula I have seen volt was equal to joules upon coulomb. So, if I take 1 volt, it will be equal to 1 joule upon 1 coulomb. So, when I define 1 volt, I will say that 1 volt will be the potential difference. When 1 joule of work is done in moving 1 coulomb of charge, right. So, how will I define 1 volt? 1 volt is defined as the 1 volt is the potential difference. 1 volt is the potential difference when 1 joule of work is done in moving 1 coulomb of charge. So, then we say that the potential difference is 1 volt. So, now you need to understand the difference between volt and 1 volt definition. Define volts, simply the SI unit of potential difference, and define 1 volt, always through the formula we will be defining it. Fine. So, this is about potential difference.